Today we're going to discuss net force. Net force can be summed up and defined as all the forces acting on an object. Okay? Now, when we calculate all the forces, we're taking into account all the contact forces, we're talking about friction, and we're talking about gravity. Okay? If the forces are balanced, well, basically that's going to result in either balanced forces or unbalanced forces. Okay? Balanced forces are going to result in the object maintaining its motion. So motion is when the forces are balanced acting on an object, the motion is going to stay the same. When the forces acting on an object are unbalanced, the motion of the object will change. Okay? Balanced forces. Balanced forces result in the net force of an object being zero. So, when the net force equals 0 newtons, the forces are balanced. Okay? So, if we had an object here, let's do our box here, and we said you have 5 newtons of force pushing it to the right, 5 newtons of force pushing it to the left, 5 newtons pushing down, and 5 newtons pushing up. All the forces are equal to each other in opposite directions, so the overall net force is 0. Okay? If that's the case, this object's motion will not change. If, for instance, let's say this object is floating through space, okay, let's say at 5 meters per second, and all those forces remain the same, it's going to continue to float through space at 5 meters per second. Okay? The motion will not change. So there's two scenarios here. Okay? The object maintains its current motion. All right? If it's moving, or it maintains its current motion and it's staying still. So as long as the forces are balanced, nothing's changing on the object. So if it's moving at 5 meters per second, it continues to move at 5 meters per second. If it's staying still, it's staying still. It's not moving at all. Okay? Examples include like holding a book or pushing on a wall or something moving in a straight line at a constant speed. All right? At a constant speed. That means it's moving straight, it's not turning, it's not moving up, it's not going down, and it's continuing at a constant speed. That means all the forces acting on it are balanced. When the forces are unbalanced, okay, that results in the net force acting on an object being anything other than 0. Okay? So the net force is not equal to 0. 0 newtons. Okay? So, if we have this box, and you have 5 newtons to the right, 5 newtons to the left, 5 newtons down, and 10 newtons pushing up, this box is going to move up. Okay, so there's going to be a change in its motion. Okay? Only unbalanced forces can change the motion of an object. The overall net force acting on this box in this example is 5 newtons up. Okay? So when something changes direction, whether it turns or goes backwards or up or down, the net force acting on that object is pushing it in that direction or pulling it in that direction. Okay? If you have any questions, please come ask us. So just remember that unbalanced forces result in the motion of an object changing. Okay? And now that means it could be sitting still, and then all of a sudden, like a ball sitting on the ground, it's sitting still. All the net forces are balanced. Then you come along and kick it. You put an unbalanced force behind the ball, pushing it in the other direction. Okay? So that changes the motion of the object. It was once still, now it's moving. Or if something's moving in a straight line and you push on it from one side and it moves to the other side, the net force becomes unbalanced and it turns. Like if you're riding a bicycle next to your friend and you're both coasting and you push your hand on their shoulder, they're going to start to just fade to the left or to the right, depending on which side you're pushing from. Okay? If you have any questions, once again, please come ask us.